Hey everyone, and welcome back to The Explainer. Today, we are taking a seriously fascinating journey. We're starting at 30,000 feet to examine a massive $133 billion global market report on electric motors and generators. But we definitely aren't stopping in the boardroom. By the end of this explainer, we're zooming all the way down to the literal nuts, bolts, and grease of industrial machinery maintenance, just to see exactly how the macro completely relies on the micro. Let's get into it.
Here's how we're going to break down this macro to micro journey. First, the global motor boom. Second, drivers of market growth. Third, innovation and industry moves. Fourth, a spotlight on vertical hollow shafts. And fifth, essential motor maintenance.
All right, part one, the global motor boom charting a massive financial trajectory. $133.07 billion. Let that number sink in for a second. That is the current market valuation for the global electric motor and generator market right now in 2025. I mean, we all know this isn't some niche industry, right? It is literally the unseen workhorse of the entire global economy. This kind of sheer financial weight perfectly reflects how deeply integrated these machines are into, well, absolutely every supply chain on Earth. From the tiniest servo motors inside your everyday electronics, all the way up to massive industrial generators, our global reliance on these machines is absolute.
And it is not slowing down anytime soon. We are tracking a steady 3.9% compound annual growth rate. That steady climb is actively propelling this market from that $133 billion mark up to a staggering $160.07 billion by 2030. Think about that. That's roughly $27 billion in brand new value created in just 5 years. It really proves that despite whatever economic roller coaster we might be on, the fundamental baseline demand for mechanized power and electricity generation isn't just stable, it is aggressively expanding. Moving on to part two, drivers of market growth. So what exactly is fueling this surge? Well, we're seeing a massive push from a few key areas. You've got surging EV adoption, the huge integration of renewable energy grids, smart factory investments, and increasingly strict efficiency regulations that are basically forcing companies to rip out and upgrade their older equipment. But you know what's really fascinating? That last point right there, rising mining activities. Recent data showed a 10.7% surge in the mineral production index. Why does that matter? Because all the raw materials we need for modern tech require heavy machinery to extract from the earth. And that demands incredibly robust, high-power electric motors for crushers, mills, and hoists. And if you're wondering where all of this is concentrated geographically, the Asia-Pacific region stands out as the undisputed dominant force. As the absolute largest regional market in 2025, it's the current heavyweight in manufacturing, industrialization, and rapid infrastructure development. They are pulling in a massive, massive share of that global demand. All right, part three, innovation and industry moves. Let's look at the corporate giants and the tech leaps. What is super interesting to me here is the wild contrast in the market strategies that are driving the space forward. On one side, you have massive corporate consolidation. Take WEG Industries, for example. They just made a monstrous $400 million acquisition of Regal Rexnord's motor business. That's a pure play to capture market share and scale up traditional manufacturing muscle. But then, on the exact opposite side, you have pure disruptive tech. There's a US company called Orbis Electric, and they just launched something called the Halo Drive. Listen to this. It's an axial flux motor that is completely magnet-free and rare earth-free. Oh, and it delivers a torque density comparable to a V8 engine, all while hitting up to 97% operational efficiency. So you can see the market is being pushed from both sides, by sheer financial gravity and by these brilliant ground-up technological leaps. Which brings us to part four, Spotlight, vertical hollow shafts. Time to zoom into the machinery itself. Okay, let's get out of the boardroom and onto the factory floor. The vertical hollow shaft, or VHS motor, is just an incredible piece of engineering designed specifically for really tough vertical installations. Unlike your standard run-of-the-mill horizontal motor, the VHS is built so the pump shaft actually passes right up through the hollow center of the motor rotor to connect directly at the top. Because of this totally unique direct mounting setup, it delivers maximum power transfer straight downward into the pumping mechanism. It is absolutely perfect for high-thrust, heavy-duty jobs. And these workhorses, they're literally everywhere. We're talking deep well and turbine pumps, massive agricultural irrigation systems, municipal water processing plants, and heavy-duty industrial cooling towers. And keep in mind, these are definitely not pristine, climate-controlled environments. They're outdoors.
They are fully exposed to dust, intense moisture, and brutal extremes. Think about it. If a VHS motor on a municipal water pump fails, city infrastructure literally stops. Nothing flows. That is exactly why understanding the big picture macroeconomic growth of this industry doesn't mean much if you don't understand the ground-level operational reliability of these specific machines.
And that leads us right into part 5, essential motor maintenance, because we've got to keep this global boom running.
Keeping a $160 billion global boom humming along requires extremely practical, everyday care. So for the operations folks out there, here is the absolutely critical 6-step maintenance checklist for vertical hollow shaft motors. First, lubrication checks for those high-stress thrust bearings. Second, inspecting your seals and grease fittings to keep water and debris locked out. Third, checking that shaft alignment to prevent premature wear. Fourth, constantly monitoring for any unusual noise or vibration. Fifth, keeping the housing and cooling paths clean so the whole thing doesn't overheat. And finally, inspecting your electrical wiring and connections. I know it sounds basic, but rigorously executing this exact methodical list is the only thing that prevents catastrophic failures and million-dollar production stoppages.
But here is a huge trap that so many people fall into. Over-lubrication can cause just as many problems as running dry. I know, it feels totally counterintuitive, right? When you're servicing high-stress equipment like thrust bearings, pumping in more grease is not always better. Actually, too much lubricant can literally blow out the seals, it can cause overheating through churning, and it invites all sorts of contamination. It requires absolute precision. You have to apply the exact recommended amount on a very strict schedule. No more, no less.
Properly maintaining these systems also means pairing the motor with the right complementary equipment to extend its lifespan. For instance, utilizing a really heavy-duty gearbox, something like the RSKF series helical gear motor. When you integrate your motor with precision-machined gears, a heavy-duty housing, and superior sealing, it takes so much of the mechanical stress off the motor itself. It keeps all that environmental dust and moisture out of the transmission, and ultimately, it drastically minimizes downtime across the entire assembly.
So there you have it. We've traveled all the way from examining a massive market preparing to hit $160 billion globally, driven by renewables and EV tech, straight down to the gritty, vital necessity of correctly greasing a single thrust bearing on a vertical hollow shaft motor. It all connects. The macro completely relies on the micro. So I'll leave you with this to think about. From billions in global growth right down to the grease on a bearing, is your equipment actually ready for the future of motion? Thank you so much for joining me on this explainer. Keep learning, keep optimizing, and I'll catch you on the next one.